Welcome class to Chapter 8 Functions. In this chapter you're going to learn how to write functions, which are named blocks of code that are designed to do one specific job. When you want to perform a particular task that you defined inside your function, you call that function responsible for that code. If you need to perform the task multiple times, you don't need to type the same code. You just simply go ahead and give another function call. You'll find that using functions makes your programs easier to read, to write, to test, and to fix. Also in this chapter, you'll learn how to pass information to functions. You will learn about arguments and parameters, with also along the way learning how to return information from a function back to a function call. And then lastly, you'll learn how to store functions in separate files called modules to help organize your main program files. For Chapter 8, I'm going to split it into 3 separate sections. In this video, we are going to cover defining a function, passing information to a function, arguments and parameters, positional and keyword arguments, default values, avoiding argument errors, and return values, along with making an argument optional. So looking at just simply the syntax for defining a function. This looks familiar to you because of your experience with alien invasion. So we have DEF space and then the name of our function, and then a set of parentheses followed by a colon, a docstring, and then the body of our function. So let's break that down. DEF, absolutely required, followed by a space. The name of your variable or name of your function should follow the same naming conventions as variables. So no spaces, things like that. So we have a set of parentheses that follows. In these parentheses we can have parameters. Okay, in this one we do not have a parameter. So it always follows with a set of parentheses whether there is information inside the parentheses or not. And then the colon. The docstring gives us information about what the function is. So it's a statement that says this is what the function does. And then following that will be our lines of code that actually will be executed and will perform that specific task. Now in the red here is the function call. So the function call is simply the name of my function, and any parameters or that are needed will be stored in arguments here inside these parentheses. So let's look at this example in greeter.py. I'm going to go ahead and run it, and I get my print statement of hello. So a very basic example using a function. Passing information to a function. So do I need to send some data along to my function using my function call? If I do that, I need to make sure that I have a variable in the function definition that will catch that information. So this is Jesse, and this is a string, and that string is going to be stored in the parameter username. So let's go ahead and add this code here. So we'll put in username, Jesse, and then we'll just go ahead and expand this code here to be a little bit more information. So hello, and then we'll use username.title. So hello, Jesse, so I could put any information in here that I want. It would be caught here, and then I can go ahead and use that as my output within my function. Now, what is the difference between a parameter and an argument? So you're going to hear these words used interchangeably. The syntax of it, or the specifics of it, is that when you use a function call, it's called an argument, and when it's caught in the function definition, it's called parameter. They are the same. So if you see it in a textbook or hear me refer to it in an opposite way, it's the same. Okay, you could use argument for both of them. You could use parameter for both of them. Passing arguments. So a function definition can have more than one parameter. Therefore, a function call may need multiple arguments. So we separate them by commas in that situation. You can also pass arguments as positional arguments, which when they're the same order as parameters are written. Keyword arguments, where we're giving kind of a key name to them, so there's a variable name associated with the value. And then you can pass arguments also as lists and dictionaries. So let's go ahead and look at our first example using positional arguments. So positional arguments means that these variables right here must be in the same order as my arguments down here. Okay, so these are parameters, these are our arguments. So hamster is going to be stored in animal type, Harry will be stored in pet name, and then if I do more than one function call, I can go ahead and send dog the second time and Willie as the name the second time. So let's go ahead and look at pets.py, where we have hamster and Harry. So this one says I have a hamster, I have an animal type. Well, that was hamster that was sent to animal type, and my hamster's name is Harry, so Harry was sent to pet name, and pet name was used with the title method. Let's go ahead and add in that second function call. So dog and Willie. Okay, so now I just have two more print statements. I have a dog, my dog's name is Willie. Keyword arguments. So keyword arguments, let me jump back here one second. In our positional arguments, you want to make sure that order is exactly the same. Okay, so let's go ahead and let's just say I flip these. Okay, let's put in Harry and hamster. So I have a Harry, my Harry's name is hamster. So again, they matter because of how the information is caught. Okay, so Harry is now an animal type, hamster is a pet name. So positional matters with order. Okay, keyword arguments, a name value pair that you pass to a function. So you have a name associated with the value. No need to worry about the order of arguments in a function call, and these also clarify the role of each argument that is then passed to our parameters. So let's look at an example. Back with describe pet, we now have animal type, which then matches to my parameter up here of animal type. Same thing here with pet name. Pet name matches up with pet underscore name. So let's go ahead and add this into our pets. And this is top of page 134. So I will go ahead and put in here animal type equals, and I'll switch these back around. And then this would be pet name equals Harry. I'll go ahead and just take this second function call out for now and run it. I get the same results. Now I can go ahead and switch these around since order doesn't matter. And I just hit Control B on my keyboard. Yep. I still get the same results. It doesn't matter the order because it knows that Harry belongs to pet name and it stores it in pet name. The same thing here with animal type. It knows hamster belongs to animal type, so it stores it in the correct parameter in the function definition. Key names must be exact. Okay, so if I have animal underscore type here, I can't have animal underscore types. Okay, so they are exact, they are case sensitive, so make sure that these variables here match these variables here. Default values. So sometimes we have maybe something that is consistent and we just want to define a default parameter. and then we can override that default parameter. So if the argument for parameter is provided in the function call, Python then uses that argument value. If not, it uses the default value. You can exclude argument in function call if you're using the default value. Python interprets arguments as positional, so when using default values, you use the defaults or position the defaults at the end of your function definition parameter list. So let's look at an example of this with default values. We'll continue our work with pets.py. So animal type, we're going to assume that most people that are using this function are going to have the animal type of dog. Now, since I'm using this as a default value, I have to position this at the end of my parameters, okay? Because they are assumed positional in nature. So always default values at the very end of your parameter list. And then now I just need to say pet name, and we'll use Willie, back to our dog example, and it will automatically assume that animal type is dog. So I have a dog, and my dog's name is Willie. Now let's say I want to override that default value. I can say Harry, animal type equals hamster. So now I'm overriding the default value. So I have a hamster, my hamster's name is Harry. So default values for something that is consistent, and then you can override it by just simply coding that extra key and value. And those were those two examples that we just went over. Okay, equivalent function calls. So there's many ways that you can go ahead and write this. So we have describe pet Willie. Okay, you could go describe pet underscore name Willie. You could do Harry and hamster. So let's go ahead and code some of these just so that we can see how these will all work. So we'll describe pet, and we'll just put in Willie. Okay. So Willie stored in the pet name, animal type being the default of dog. Okay. Or if you wanted to include, you could put pet name equal, same results. We can go to the hamster example where we can say Harry. See how this works. I'm kind of questioning this example, but hamster. It works. Okay. So I have a hamster, so we didn't even have to define the key over here. Harry goes into pet name. We're overriding the default with hamster. It's okay to question. So then you could add these in where pet name, animal type, same results. Okay, and then again, I already gave you the example where you could go ahead and switch these around because now we have those keys and we would still get the same results. So lots of different equivalent function calls that you can create to call just one function when working with keyword arguments. Avoiding argument errors. So sometimes I see this when I get a request to debug alien invasion. And we'll see this more as we start to build more into that project. So describe pet missing two required positional arguments, and it says animal type and pet name. So let's recreate that over here by just doing this. And we have, this one has missing one required positional argument, and that's simply because we have a default. Well, let's just change this back where we don't have a default. And now we have two required positional arguments, pet name and animal type. So how they are, how many you have, is how many you should have here. Now the exception is self. So in our alien invasion, you will see self, comma, and then a list of parameters. Self is not repeated in the function call. Okay, so if you see self like this, you would still only need two positional arguments here because this one and this one. And we'll talk about self when we start getting into classes. So I'm going to unwrap this so I can get it back to what it was before. Let's now talk about the labs that will be for this section, and they are 8-3 and 8-4 on page 137. So 8-3 t-shirt, write a function called make shirt that accepts a size and a text of a message that should be printed on the shirt. This function should print a sentence summarizing the size of the shirt and the message printed on it. Call the function once using positional arguments to make a shirt. Call the function a second time using keyword arguments. Okay, so you're going to define two parameters and you're going to call this function twice, once using positional arguments and the second time using keyword arguments. 8-4 large shirts, modify the make shirt function so that the shirts are large by default. Okay, so now using a default value, make sure you use that parameter as the last one, with a message that reads, I love Python. Make a large shirt and a medium shirt with the default message, and a shirt of any size with a different message. Okay, so 3 function calls for 8-4. If you have any questions on either of those or anything that we covered in the first section of Chapter 8, please let me know. Thank you.